So our next speaker is Kristen MacMillan. She is fantastic. Kristen is a great teacher, and she is a super dedicated researcher. She's been out in the field with soybeans and pulse crops for over a decade, and she's been doing farm fields and research plots. She was actually used to work for, or part of Manitoba Pulse and Soybean Growers, and she was extremely pivotal, and she really helped develop and get organized the very first kind of research and extension strategies that MPSG took on. So Kristen then later had the opportunity to come back to the University of Manitoba, and like Terry mentioned, Kristen is our agronomist in residence at the University of Manitoba. She does a little bit of teaching, but lots of field work still, and the wonderful thing about Kristen is she does practice what she preaches. She grows soybeans and peas, and some other crops and cattle with her husband and their very busy young family at Marquette, Manitoba. So please join me in welcoming Kristen MacMillan.
I have to use this one because the batteries, but it's this one's batteries are dying. Oh, there we go. Okay, thanks for that, Wendy. And good morning, everybody. Let me just figure out which hands I'm going to use here. Okay. So yes, thanks for that introduction, Wendy, and good morning to everybody, and thanks for coming out on this Thursday morning of Ag Days. I also want to say thanks to Terry. I have known Terry for as long as I've been in this industry, and I learned something new, that he has a degree in psychology. So that's interesting, and I also appreciated the Billy Bob impressions. I think that was a good way to wake us all up and warm us up. So I know in the Ag Days trade show guide, the title is Checking Your Research Pulse. So I guess the title that I submitted was a little bit too boring, but this is the title that I submitted because what I'm really happy about right now is celebrating going into the 10th growing season of my research program. So that's why I have this title up here. It's 10 years of the Soybean and Pulse Agronomy Research Program. So before we begin, you may be wondering, what is the Agronomist in Residence program? So I'm an agronomist, I'm doing research, and I'm in residence. So the in residence part just basically means that I don't have tenure. I'm not a tenure track professor at the U of M. I have terms that I renew with funding from Manitoba Pulse and Soybean Growers, which isn't necessarily a bad thing because I need to prove that those checkoff dollars are being put to good use. And that's what I'm doing here today, is to share with you the research that I've been doing over the past 10 years. So what it is it's a unique research position that's commodity focused. So I work strictly on soybeans, pulses, and dry beans, and I work on applied agronomy research questions. So these questions, when I start a project, I say to myself, am I informing or improving production practices that farmers are using on their farms today, or that agronomists are advising farmers to use? It's very close to practical application compared to more upstream research projects that are done at the university that might be done like in the controlled growth rooms that Terry had on the screen here earlier. And it also has targeted teaching and extension. And I should also, this was initiated and funded by Manitoba Pulse and Soybean Growers back in 2017. Now what makes it distinct from others, my colleagues at the university, they also have research, teaching, and service in more traditional academic positions. But because of that directed funding, the work that I do is very targeted. Again, focused on farmer and field questions. And two examples I have of that is that I make it a priority to report on every research project that I have. So all of my research activity, I prioritize publishing an annual report. So I would prioritize that over perhaps submitting a publication to a scientific research journal, as an example. Or the teaching that I do is focused on diploma students who are really future farmers, and I see a few here in the audience. Whereas traditional academic positions may have many graduate students, and they're working more on training future scientists. And like I mentioned, this was established in 2017, and it was really for a few reasons. Many of us might remember the change that Manitoba Agriculture went with their extension services, closure of more of the district offices, more centralization. So there was a gap in extension, and that bridge between research and extension was widening. It was also in the need to adapt soybean to our cropping landscape. So in 2017, that was also the year that we hit over 2 million acres of soybeans. So farmers, just like us on our farm, we started growing soybeans. We had all these production questions that we needed to adapt to Manitoba conditions. Most of our knowledge was coming from the US. Also to continually evaluate production practices of our other crops, so peas and dry beans, which have been on our landscape for many decades. But as cropping systems evolve, technology comes in, we need to continually update production practices for those crops as well. And so this was the strategy, and I think it's working fairly well. You may have heard the recent announcement that Manitoba Crop Alliance also has an agronomist in residence as of last year, focusing on special crops. And there's also another agronomist in residence position here in Brandon at Assiniboine College. The other thing that I wanted to mention is that it's been a strategy to increase applied research and extension here in Canada, because often, and maybe this is more in the academic world, we talk about land-grant universities in the US. And at those institutions, research and extension are one of each other. So academic positions in universities have a very strong and high extension role, versus here in Manitoba and most areas of Canada, they're quite separate. And in fact, those land-grant universities have a mandate to focus on the teaching of practical agriculture. So this has kind of been our Made in Manitoba version of that. Okay, so research projects. Here is a listing of all of the research that I've conducted in this program over the past 10 years. So you can see it spans soybeans, peas, dry beans, and the ones that are highlighted in green, I don't think I can put a laser pointer, but the ones in green are my active research projects. So in any growing season, I have anywhere from 5 to 10 projects, and each of those have probably 2 to 3 site years. So I'll conduct an experiment at Carmen, Melita, Arborg, maybe Dauphin. And each of these projects I report on in an annual report. It's actually more like a biannual report. Turns out I've been doing it about every 2 years. And so I have the QR code, I have it up there at the end. So all the results, preliminary results, I try to report on projects even if they're not fully complete, just to get the word out there and to get farmers and agronomists to start thinking about what results are coming down the pipeline. And also, as Wendy mentioned, I have 3 other research projects that are listed here. And if you've heard me speak, I do try to integrate both the farming side and the family aspect. Plus, they're at the age now where they're wearing tutus to the field, and how adorable is that? Okay, I mentioned teaching. So I've been teaching, I developed a field scouting course for diploma students, and I've had 5 to 10 students each year. And the primary learning component in this course is scouting a soybean field every week throughout the growing season and making recommendations or decisions as if they were the agronomist or the farmer. So this has been a real highlight for me. And just this past fall, I started teaching the first year crop production course to the whole first year class. So that was a really new experience and quite rewarding for me as well. Okay, for the first, for a few more minutes here, I'm gonna just fly through some highlights of past research projects. So some of you may recall or have heard about this, but this project was actually initiated by farmers out here in the West who had been hit by hailstorms, a tornado, back in like 2013, 2014. And this was when I was still the production agronomist with Manitoba Pulse and soybean growers. And I was getting called out to the field saying, crop insurance adjusters are coming out and telling me this much yield loss from the hail, and I disagree, I think it's way more. And so we realized that the data that crop insurance has for adjusting is based on US data. So this was probably, I think, the first project that I initiated, looking at how stem breakage and defoliation affects soybean maturity and yield in Manitoba. And the summary basically is that yes, it confirmed what farmers and agronomists were suspecting, that yield loss estimates were underestimated for Manitoba compared to US. And you can see the gap, the dotted red line there basically shows anywhere from 6 to 25% underestimation of hail damage to soybeans. And I have to include this picture because it's probably still the most intensive research I've done. There's about 15 of us plucking leaves on soybean plants in those plots to get different levels of leaf defoliation. One project that I feel didn't get the traction was investigating intercropping and relay cropping. So over the course of 6 years, I looked at relay cropping, fall rye and winter wheat with soybean and dry bean, as well as intercrop combinations, pea canola, pea flax. And this is summarized here, but long story short, relay crop soybeans and winter wheat has been a bit of a bust here in Manitoba. We simply don't have the seasonal precipitation to take 2 crops to harvest. At best, I could get about 50% of the winter cereal yield, but I would struggle to get 1/3 of the soybean yield in this relay crop system. But it made for some really nice pictures, and there was a lot of chatter of this among farmers from the US. The most reliable kind of diversified system that we've tested has been pea canola, and there's about 10,000 acres of that in Manitoba. Another one that's been interesting, and I think might be worth testing further, is a winter cereal with peas. And then they're harvested together, so at least the economics look a little bit better instead of 2 harvest operations like you would with relay crop winter wheat and soybeans. So still not as competitive as monocrops on their own, but I know there was and has been a lot of interest and questions, so I did explore this. Seeding date studies. This data you probably are all very familiar with. When soybeans first came to Manitoba, we were very strong on the wait till soils at least 10 degrees Celsius and warmer. Now we know that the seeding window is fairly flexible throughout the first 3 weeks of May. If that soil's 8 degrees and warming, then farmers are going to go at it. On the opposite end of that, what about late seeding? So similar, this was also initiated by farmer questions, was how late can we plant soybeans in Manitoba? And this has been because of the introduction of early maturing cultivars to Manitoba. And the seeding deadlines were initiated back in 2005, before those early maturing cultivars really started to take off. And so, long story short, this was done in each of the test areas, and that data contributed to an extension of soybean seeding deadlines. Soybean yield response to seed depth. So this has been one of the agronomy practices that has had the most influence on soybean yield, I would say. We found that yield maximization, it's important to get soybeans seeded about 1.25 inches, within 1/2 inch of that range. Very shallow and very deep seeding, we could see 10-20% yield loss. Again, this question came, we've been facing wet conditions, dry conditions, and we've had the extremes of deep seeding to chase moisture or shallow seeding, very shallow seeding in some situations. Okay, so that's kind of wrapping up some highlights. Now I want to spend about 10 minutes on 2 current projects. The first one is, and the way to introduce this is I'll say, have you considered rolling soybeans post-emergence? And I'm going to see if this will work. Okay, if some of you want to join with your phone and do my survey here, I'd be curious to hear when you roll soybeans. So you just scan the QR code and put in your answer there. Let's see what the audience has to say here. Okay. So it's not telling me how many respondents we have, but most of us are going to be soon after seeding. Okay, no surprise there. 1 or 2 of you maybe are doing post-emergent rolling, so that's really interesting. Let's talk about that. Okay, but definitely most of us are seeding the soybeans and then rolling if we have to. About 10% of you are not rolling, so you're probably on really nice soil with no stones. Okay, so just so you know, why are we rolling? We are essentially rolling to get that nice smooth seed bed, right? We know soybeans pod very close to the ground. So if you're like me in the interlake and you have stones, we want to push those down. Maybe you're breaking up root balls of corn stalks, and we're smoothing that soil surface. However, there are unintended consequences of this. So we know what that rolling does is we're crushing those soil aggregates. Okay, we're dispersing them into very fine particles, and that's creating or can create two issues. The first is sealing of the surface, a crust that occurs, right? And I see this each year. We finally get that rain, or the rain never stops, depends what year we're talking about. And I look at the fields and I just see that water hitting the ground and just pooling and moving off, not infiltrating the way we want it to. And considering that moisture deficit has been such a challenge for us, that's not ideal. We want to utilize that rainfall. What else happens when those soil particles are dispersed? The wind picks up, right? We've all seen this. This was actually, I hate to say this, to throw our farm here, but I love to use examples. You know, Terry was talking about the psychology of people, and I definitely know about myself, I always have to include things from our own farm. We're constantly learning from our own experiences. So this is one of our fields. It's a full mile, and that soil's blowing, like the worst we've ever seen. This was an exceptional scenario where we had just broken a hay piece and applied manure, so it was very excessively tilled. So that's worst case scenario, but it creates quite an impact there, right? We've seen this. So is this an option? And I should also mention, that wasn't even a soybean field. That was wheat ground. So we're also rolling, if we really have stones, we're rolling other crops as well. And this is something that we should consider in other crops too. It's something that we don't really talk about. Okay, so to set the stage for the research project, here is my technician Brody, who I should thank as well. He makes all these field trials possible. Here we are in our rolling experiment, and you can see we have about 10 plots there, and the treatment is rolling at different timings and under different weather conditions. So this I thought was a good video. It just kind of shows you experimental design. It gives you a view of the research farm in Carmen. This is a drone, and then we can see the impact that the rolling had on the plants. All right, so let's put some data on that. Here are the rolling treatments. Like I mentioned, they're crop stage by weather conditions. So we had our unrolled check, then we rolled post-seeding, like most of us are doing. Then we rolled at different timings. Emergence, when the cotyledon was unfolded, unifoliate, V1 or V2, V3, V4, and then all the way at flowering. And at each one of those timings, we tried to get different weather conditions. Warm and sunny, which is what we would recommend for post-emergence rolling when the plants have less turgor, less moisture in them, and then on a cool, cloudy day when those plants might be a little bit more brittle. Okay, first treatment, rolling at the cotyledon stage. And there's a few things I want to point out here. First, the plant looks differently within the cotyledon stage. So this arch is not when we roll. That stage only lasts 1 or 2 days, and we still think that that's probably a fragile stage of the plant. Most of our plants were when the cotyledons were unfolded. Okay, so that's something to keep in mind. So that's when we rolled. You can see that in the picture here. The other thing I want you to see is that there's obviously a furrow, right, that the seed's planted in, that's packed down, and the plants emerge within. This is quite important when we think about how a roller impacts the plant. It's actually protective. So here it is after rolling, and you can see where that furrow gets flattened by a wheel, and then the impact of the roller is higher. that's when we start to see plant damage. But where the furrow, if their plants are protected, really no damage at all. And so here I just did a little drawing of where the plants were actually killed or not. So at this cotyledon stage, only about 1% of the plants in the plot were broken. This was really surprising. I've done this for 2 years now. Okay, rolling at the next stage, unifoliate leaves now. Okay, I think I have a video for this one. So this is like another week later. I think you could see the odd unifoliate leaf clipped off by the roller. Damage in the tire track, which I'll explain a little bit more in another slide or two. But overall, it's looking good. I think less than 3% of the plants were broken at this stage. Okay, plants are getting bigger now. We're at first to second trifoliate. Bouncing back very nicely. And just another angle. Okay, are we surprised by this? Do you have a question? The speed of rolling? So yes, I was just talking about this earlier. We are probably 3 miles an hour, maybe, a little bit slower than a field situation, yes. But on this, since you asked, we also, our drum, or like our roller, is actually a little bit heavier than a commercial roller. So if anything, the conditions that we're testing this in might be more damaging, which is kind of a safer position for me to be in research. Heavier roller, maybe a little slower, and then I'll talk about the tire tracks in a minute too. Okay, so yes, still, so more plant damage, but less than 10%. Still safe, did not see yield loss from this. Now we're entering the danger zone. 3rd to 4th trifoliate, we're getting to the end of June. If you haven't had a window to roll at this point, you need to proceed with caution. Oh, no, I don't have a video for that one, but you can see the stem breakage that's happening. And what's interesting about this, so this question's also been asked in Minnesota and North Dakota, and their data shows that it's safe at V3 to V4. This is the first stage where I'm starting to see contrasting results from the US data. Here's a picture of what the 2 plots look like unrolled and rolled at that stage. Starting to see 17% plants broken. I'm expecting to see some yield loss from that. And there you can see tire track, 24% of plants, compared to the other rows, which is only 9%. So more than double. Most of the plant damage is happening from the tire tracks. Okay, and just for fun, this was really late. We did not expect this to go well. And it was pretty clear when I was videotaping this that those plants did not look happy after being rolled when they're flowering. So this is like first week of July. High level of stem breakage, easily seen. And I would expect yield loss just from that plant stand reduction here. And there we have it. Almost half the plants were broken following rolling at R1. Okay, so about those tire tracks, yes, greater damage, about 2 times the number of broken plants compared to the other rows. This is also going to depend on your tires and what tractor you're using to roll. And just to kind of address that question, well, you're in a research plot, how does this compare to field conditions? Here's a diagram of what my plot looks like with the tractor I'm using. I'm hitting a row, or about 16 to 25% of my plot area with a tire, which is not unlike what's happening in field situations. So here I took our farm, we have a 50-foot roller, 10-inch plant row spacing, so I have 60 rows there, and depending if we're using a front wheel assist or a 4-wheel drive tractor, I calculated how many of the rows are affected by a tire track, and it's within the range. A wider range, depending if you're using front wheel assist versus four-wheel drive. But again, we're kind of on the higher end. So here we have the yield results, which follows the level of plant damage. So we start to see yield loss when we push rolling to the third to fourth trifoliate through R1. But good news, there is a window. They can be rolled post-emergence. And this has been, so I'm year 2 out of 3 in this study. Okay, and it can help reduce those soil impacts. Okay? So here's the summary, and you basically have a 2 to 3-week window. The first 3 weeks of June is when soybeans are going to be at unfolded cotyledon through to V2. Okay? Okay, next topic that I'm going to spend a bit more time on is another current/past research experiment. This one wrapped up in 23, but I just got around to analyzing that third year of data, again going back to that picture of the 3 kids. So sometimes I use them as my reason. And the questions that I'm asking in this experiment are, how does iron deficiency chlorosis affect yield in soybean? And is there a trade-off between IDC score and yield? I think I have another survey question coming up as well. So I'm assuming everyone is very familiar by now with IDC of soybean. And just as a reminder, if IDC is a problem on your farm, you're getting information from the Variety Evaluation Guide. Variety selection is our best defense. There are genetic differences in their tolerance to this. And that picture I showed you of all the row plots is the site at Winnipeg where Manitoba Agriculture rates the varieties for their response to IDC each year. The rating scale, here's the rating scale that's used. So when we say you want a low IDC score, that means higher tolerance, greener plants. Okay, the question actually is coming up in a few slides. So like I said, this is kind of like a 2-part question. I'm going to take this one a little bit slower. So the first question is, how does iron deficiency chlorosis affect yield? So really it's a highly visual condition, right? We're choosing varieties based on their visual response. But what is the actual yield correlation to that? So what I did is I collaborated with Dennis Lang of Manitoba Agriculture and took those single row plots to yield for 6 years. So we could see what that relationship is between IDC score and yield. So here's the results of that. This has been repeated or reported quite a bit already, but the Coles Notes version is that in IDC areas of the field, yes, yield loss is happening, and it's about a 1.5 to 2.8 bushel per acre yield loss for each 0.1 unit increase in IDC score. So what does that mean on a field basis? So here are pictures of some of our fields. This one field has very high carbonates throughout. And so here where I have 2, it's actually a side-by-side of 2 varieties. We switched halfway through this field, and they differ in IDC score. So what I'm expecting based on that data is we're probably losing 3 to 6 bushels on average across most of that field because of that difference in the response of the varieties. Same thing here, but the difference in this field is it's only for small areas of the field. Okay? Which leads me to my question for you. When IDC is present, what % of your field is normally affected on average? Okay, and if it's not an issue for you, then I might put you to sleep here for a few minutes. Okay, so, there we go, jump to the top. Yeah, So most of us, this is what I expect, this is what I've gotten in terms of responses when I've polled farmers before, is that it's really only happening in about a quarter of our fields. But we're making a management decision for the whole field based on that quarter. Okay, so maybe you know where I'm going with this next question. Is that the best decision? Do we know the answer to that question? Now, the second question from that first title slide, is there a trade-off between IDC score and yield? Is the variety we're choosing for that 25% also maximizing yield where IDC doesn't occur? We didn't know the answer to this question until just now, just recently. I'm going to show you. In order to answer this question, we have to evaluate the yield potential of the varieties in an IDC area of the field and a non-IDC area of the same field. Okay, going back to controlled conditions, we need to control as many factors as possible. This hasn't been done before until just now. So basically what that looks like, say I have this field that has IDC areas, whether it's low spots, high areas of nitrates, whatever it may be. I set up a trial in that part of the field, set up a trial in that part of the field, same varieties. So we did this at that IDC site with Manitoba Agriculture. We just planted another trial a few hundred yards away in the non-IDC area of the field. And this is important because yes, we do have IDC data in the variety guide, and yes, we do have yield data, but the yield data are from the McVet sites, not from the IDC site. So we have that confounding effect of different field environments. Okay, just as a reminder, I took these three figures from the earlier slide. This is the data from 3 years under IDC conditions, so I already showed you this. Yield is negatively correlated to IDC score in IDC areas. You want a low score for high yield. This is the new data. What's happening in the non-IDC area of the field? So what we're finding is that yield is also negatively correlated with IDC score or not related at all. So this is good news. The varieties we're choosing for low IDC score are also doing well in non-IDC areas of the field. Okay, so this has been really good new news for Manitoba soybean farmers. Now to take it a step further, because each year those varieties that are being evaluated change, I said to Dennis, I'm like, we need to get a common set of varieties and test those over multiple years. So I identified varieties like in 2021 and 2022, and I said, let's make sure we get at least this set of varieties also planted in 23, so we can have 3 years of data for each of these varieties. And I did the same thing, asking the same question. Okay, now with this data set of a common set of varieties, is there a yield trade-off? Same negative relationship there, and same thing. So it just confirms that there is no evidence of a trade-off. Now, why am I asking this question? Because in North Dakota and South Dakota, they have found evidence of a yield trade-off. So what that would look like is if in non-IDC areas, varieties with low IDC score were actually yielding lower in non-IDC areas. So genetically selecting for IDC was negatively selecting for yield. It has been shown in some soybean populations. So if IDC is a constraint in your fields or your clients' fields, continue choosing varieties with low IDC score and high yield. Okay, so this is just confirming our practice. Yes?
When you did these trials, did you take the IDC conditions straight through to maturity, or were sometimes the IDC only present?
Okay, so IDC usually only happens for a few weeks, like second week of June through the third week of July. So we took the trials to harvest, and we harvested them to maturity. But to answer the question on how long the presence of the IDC occurs, it fluctuated each year. Some years were worse than others. I would say anywhere from 7 to 21 days is how long these symptoms would persist. And the longer they persist, we expect higher yield loss, okay? And the ratings were taken over a series of weeks as well. And the average is what I'm using here. Okay, and then I also just highlighted what I would consider for Eastman and Westman low IDC score, high yield varieties. Okay, another way to come at this angle, another reason why, other than the data from North Dakota and South Dakota, but I mentioned, precision ag and the ability to zone map our fields and potentially plant more than one cultivar. So if you just humor me, I'm gonna play out that situation. We kind of know the answer because I'm telling you that there is no yield trade-off, but I just want to show you how that pans out if we were to go down that road. So here's the results. And so I'm showing you the 3 varieties that have the highest yields in IDC conditions and the 3 varieties that have the highest yield in the non-IDC conditions and the highest with the overall. As you can see, it's quite common. If it yields well in one area, it's going to yield well overall. So let's take these different field scenarios where you have no IDC or you have a field that's mostly IDC, and then let's say you planted each of those top cultivars, or say you planted both. Which scenario is best for you? So because most of us are facing fields that have 25 to 50% of IDC, you can see here that the best scenario is just choosing the highest yielding varieties. There is no scenario where multi-planting, we're really just picking hairs here. So both means that I put the highest IDC variety in the IDC areas and vice versa. So this is just showing us that if you don't have a yield trade-off, there's no case to do that, to pursue that. You might have a case where if your field is almost entirely affected by IDC, then we start to see a yield advantage with that one cultivar that's particularly strong in IDC. But for the most part, what we're doing is the best strategy. Now to wrap up this part, would these varieties be selected based on current available data? Because remember, I'm using data from those field trials in the IDC area. But when we open up the variety guide, we have IDC scores and yield from other sites. And the answer is yes. So in 3 out of 4 of these varieties, I would look at the guide and choose those based on current available data. There's always going to be scenarios, especially in soybean, where variety is such an important component of yield maximization. But the problem is that there's so many soybean varieties and the market turns over so quickly, new herbicide genetics, this and that. So to continue doing very variety-specific research, that we don't have a strong case for this. I mean, I could do it, but 3 times out of 4, we're doing the right thing. Okay, last few minutes here, I'm just gonna touch on 2 ongoing experiments as well. I don't have results for this one. This is, for the pea growers in the room, a long-term pea cropping intensity trial, okay? This is at Carmen, and this is just a drone photo of it. Here are the treatments. It's looking at 3, 5, and 7-year rotation of peas, okay? Because we know that Aphanomyces is our biggest enemy, and the recommendation is 6 to 8 years away from peas if you have a history of Aphanomyces. But a gap in the literature is that that's not based, we don't have many, if any, field studies to back that up. So this was established in 2021 to help build the literature on how crop rotation affects Aphanomyces in Manitoba, especially in Manitoba where we're starting, or where many of us, some of us, are starting as new pea growers. So how does Aphanomyces build up in these relatively new fields, okay? I also have a control of soybean, wheat, canola, and a control of cereals only. So this is allowing me to ask the following questions. How does the number of years between pea crops affect Aphanomyces and pea yield and the economics of that? But because I have those two controls, I'm also starting to ask the question of how does the frequency of N-fixing crops, so broadening it out to include the soybeans that I have in rotation, how does that affect the soil and cropping system? How does it affect soil carbon, soil nitrogen cycling? So these are some of the new questions that we're getting into. This is only in year 5. So this past growing season was the first year where I have a comparison of peas grown every 3 years to peas grown every 5 years. It'll be another 2 years before I can show you data on peas grown every 3, 5, and 7 years. I also send soil and root samples to microbiologists and pathologists in Saskatchewan and Alberta, and they sent me this really scientific looking graph in the fall, and they're looking at the species of Aphanomyces and how that differs even where they are in the soil, whether they're in the bulk soil, they're infecting the plant roots, or the rhizosphere. So this is brand new knowledge for them as well, starting at the very beginning, like how many species of Aphanomyces, how do they compete in Manitoba conditions, and which ones are actually contributing to yield and disease presence, yield loss and disease presence. So this is going to be a few years down the road. All right, dry beans. This question of nitrogen management I've been working on also since I started at the university in 2017, and it started with asking the question, okay, we fertilize dry beans, even though they're a legume, but they're inefficient. The reason we're fertilizing them is because they're poor at fixing N compared to soybeans and peas. So I thought, okay, well, we need to update nitrogen fertilizer recommendations because we have higher yields, more history. Some of the first results were showing a non-economical yield response to fertilizer, which was really surprising. I didn't expect that. I thought, okay, if anything, we'd have to increase fertilizer rates because we're getting such high bean yields these days. So that led to the question of if they're not responding economically to the fertilizer, where are they getting their N? Well, now I'm down the rabbit hole of measuring N fixation in dry beans. So it turns out they are fixing N, but the challenge now is that the amount of N that they fix depends on their environment. So how much N they fix at Scott's site in Melita might be different than what they're doing in Portage and Carmen. So now those are some really broad questions, or upstream questions you might say. There's some differences in rhizobia species that are responsible for the N fixation in dry beans, and those rhizobia are a lot more diverse and competitive compared to soybean. So that's where I'm at with this. I'm also I've tested commercial inoculants, and I'm also working with a microbiologist in dry beans to test some Manitoba-made inoculants. So this is really exciting work, potentially big impact for nitrogen fertilizer use in dry beans. So if you're a dry bean grower and you haven't heard about this yet, or if you have, stay tuned for continual updates. And this project is second to the hail damage study in terms of intensity, because there's about probably 1,000 roots here that we rate each year at each site, and we do this probably for 3 days of our summer, at least, is rating roots in dry beans. So it's fun. I like to get out to the field. All right, my last slide here is an open-ended question. So you've gotten a taste for the type of research that I'm doing at the university. I have two, actually I forgot to mention, the seeding depth study and the seed date study I'm also doing in dry beans. Those are my new projects hopefully, I'm waiting for funding approval, but those are gonna be the new projects this year. And I'm always thinking like a year or two down the road on what questions farmers have, what questions agronomists have. So open-ended, maybe you want to see me continue doing work on varieties and IDC responses, whatever is important to you. So that's an open-ended question. I don't know if they'll show what the audience says here. I only have one participant typing. Okay. All right, and with that, I would like to say thank you to all of you, to MPSG for the research funding, to my research team. I'm doing what I love every day, research, teaching, extension, so it's awesome. This was a tour. MPSG board and staff came and toured my research experiments at Carmen this year, and so that's a highlight of the summer. So, and with that, if there's time for questions, I would be happy to take them. Thank you. Yes. Yep.
So, Kristen will be around, so if you'd rather have a one-on-one conversation with her, I just want to thank Kristen for making it so interactive and she's so easy to listen to, isn't she? And she gets the point across, like, this is what we wondered, this is what we found out, and I really, really appreciate that in research. Can you all join me in thanking Kristen for presenting this morning?